My recording, and I'm going to share my screen, and this will be online for you to access as well. Okay. So, all right. So again, as I mentioned before, 4 goals before the next knowledge check. I'm going to add logs, or I'll probably add logs, but graph exponential functions with transformations, solve exponential word problems, interest, as could be interest rates, solve exponential problems with the same base, graph rationals with transformations. So we'll do all of that by the time March 30th, 29th, 39th, 29th, 29, 30 happens. Okay. All right. Here we go. Let's go with a few of these problems here. Let's just try to review some of these. And these are on your slides too, by the way. I put it on Canvas, but let's try to review some of these things here. What's number 1? Just 16. Good job. Right? -4 times -4, 16. What about number 2? -16, right? Because why? Order of operations, right? 4 squared first and then the negative. So you have to kind of be careful because sometimes this is kind of confusing because sometimes the -4 is implied, like and then sometimes they trick you where you have to multiply 4 squared first and then multiply be -16 in this situation. But you got to think about the context. The context here is they give you this and then they give you this problem right afterwards. So that's why it's -16. All right. Number 3, this is what? 9 times -8, right? So what is it equal to? -72. Good. What about number 4? A to the 5th power, right? Because when you multiply with the same base, you add the exponents. Okay. What about number 5? 6. Yeah, this is a 6. So it's what? D to the. This one's just 10. You remember, you're still multiplying, right? So when you're multiplying, you're adding the exponents. It's just to the 10th power. What about number 6 though? X to the 12. That's where you multiply, right? This is pretty much what? X to the 4th power times X to the 4th power times X to the 4th power. So you're adding 4 3 times, or you're multiplying 4 and 3. Any questions on that? Okay. It's easy until you have to do it, and it's like sometimes do you know when to apply this? It's kind of difficult. But number 7, what's 2 to the 4th power? 16, right? X 8 Y 12. Good. Multiply the exponents here. All right. Number 8, what's anything to the 0 power? 1, right? So it's just pretty much Z squared, right? What about number 9? Good job. This is huge. 1 over x cubed. So many people do -x cubed. Do not do that. No, no. Okay. No. 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 Okay. There's nothing negative about a negative exponent. That's what's hard to. So again, a lot of your impulses go one way, and just be careful with this stuff. This again, when you see the problem, it's easy. But when you have to apply it yourself, that's where it gets kind of difficult. Number 10. 1 over 5 squared, right? Because the negative exponent goes to the bottom, right? And so this ends up equaling 1 over 25. We good? Number 11. On the difficult end a little bit. -2 times 6 times 1 is what? -12, right? X squared, x cubed, x squared is what? X to the. What is it? 12? 7. Okay, 7, because you're just adding them. Okay. Cool. All right. And again, you should have practiced some of this on Delta Math last week. All right. That was the gist of what I was trying to get across. Okay. All right. Number 12. Let's focus on the exponent first. What is that? What happens to the a -2? It goes down. So it becomes 12 and then 4a to the 2nd power. Then what happens? Simplify 12 and 4, which is 3 over a squared. Always leave your exponents positive. Thank you. Okay. Cool. Any questions on that portion? All right. Cool. All right. I think we're good here. I don't think we need to use a calculator. All right, let's sketch this graph here. Okay. Let's focus on this right here. And I want to start, this is the start of graphing exponential functions here. All right. This is pretty much y is equal to 2 to the x power. All right. And we're going to plug in, let's plug in numbers, a few negative ones like -3, -2, -1, 0, 1, 2, and 3. Well, this one could be kind of fast here. So y is equal to what? 2 to the -3 power. What's 2 to the -3 power equal to? 1 over 2 to the third power, which is equal to what? 1 over 8. You guys see that? What about this one? Y is equal to 2 to the -2 power, which is 1 over 2 squared, which is what? 1 over what? 4. Good. Are we getting this? All right. Let me know if you are having trouble. Y is equal to 2 to the -1 power, which is what? 1 over 2 to the first power, which is 1/2. What do you realize? What's happening with these fractions? Are they going up or down? They're trying to go up, right? The 1/8. What if I went to -4? What would happen if I got -4? It'd be 1/60. So that's getting smaller and smaller. Let me ask you this: where do you think you'll ever hit 0? No. No. So let's think about that. Think about that process before when we graph. Okay. Y is equal to 2 to the 0 power, which is what? 1, right? Anything to the 0 power is 1, right? Okay. Then this is y is equal to 2 to the first power, which is 2. And then what? Y is equal to 2 to the second power, which is 4. And then look at the explosion here. Y is equal to 2 to the third power, which is 8. Okay. By the way, I'm a big proponent of, like, exponents are such a powerful practical analogy for life kind of thing. Okay. This is kind of what happened to me. And I actually, like some of you guys on the volleyball team, like, we're in the beginning, it's rough, right? I mean, you guys, we've all been through the struggle. I mean, whether you're any team, actually, all of you guys, it's not just volleyball. It's like any team, we're struggling, right? Some of you guys in football, it's like, oh, we just scored a touchdown. Baseball, oh, we barely scored a run. Baseball always claims that they've always been good, but hey, they struggle too, right? Volleyball, basketball, like, hey, we're barely struggling. Inch by inch, you go, and it looks like you're not really moving, right? You go from an eighth to a fourth, right? A fourth to 1/2, right? And then 1/2 to 1. And then all of a sudden, once you're established, what? You just start to boom, and it goes straight up. All right. Once you kind of things start clicking, it's like, oh, dude, like, I feel like, I don't know if you guys watched the Lakers season this year, but I feel that's kind of like what the Lakers are going through right now a little bit. Is like they sucked, they lost like the first 10, right, something like that, and then they won the next 8 of, and then they just keep going up and down, and they're finally starting to kind of hit their stride a little bit, and you're hoping that bam, it just goes and everything just goes straight up. Okay, so me as a coach, like, I am, the reason why I coach is because I know that this portion right here takes a long time. Okay, but once everybody clicks, it shoots up pretty fast. Trust me. Okay, it's like once everybody knows, it's like, oh, okay, everything is clicking on all cylinders. It's like, oh, it's pretty sweet. Okay, so all of you guys, like, whatever sport you're in, like, just hang in there, because there is kind of a light at the end of the tunnel. Like, and even if there isn't, at least you're trying, kind of thing. There has to be that effort. right? If you don't have the effort, you'll never get to a certain point. Same thing financially. Like all of you, a lot of people today, and I hate it. A lot of people today, like, oh, I'm poor because of this. I'm poor because of this. I'm poor because of this. You save up like 10, 15 bucks a month. Then that increases to like 30 bucks a month. Then that increases to like $100 a month. All right. That increases to like $1,000 a month. You get to that level where you're saving a few $100 a month, you guys will become a millionaire by the time you're like 50 years old. Okay. Right now, you guys have the advantage of time. Like I have less of that, obviously. I have like what? I'm like 20 years on, like I'm like 20 years, 30 years older than you guys. You guys, in those 20 years, your advancement could go up so much faster than for myself. Okay, so just be aware of like exponents. Like if you keep doubling your money over and over again, right? There's one guy who said you only have to double your money, like I think 5 or 6 times to become like a millionaire kind of thing. And so again, just think about the rat race of it all. Don't think like and what sucks about you guys too, what sucks about, sorry, not you guys, but this generation is like you guys go on YouTube and then you go on YouTube and then you see all these people who are like, I get rich quick. You know, hey, I got money, you know, I did this and everybody wants to get rich quick. You know, everyone wants to win the lottery, everyone wants to, but that's not going to happen. Okay, just know that's not going to happen. Oh, Mr. Ch, you're breaking my dreams. No, it's not going to happen. Okay, just trust me. All right, you will not win the lottery. You could buy 1,000,000 lottery tickets and you'll still not win the lottery. Okay, trust me. All right. So everything is built slowly. You build it slowly. Everything will be a lot better later on. Okay, so just understand like the whole exponential function. Yeah.
Are you saying that we should save $1 every day?
I think so. Yeah. I think that'd be great. And then later on, if you can save $2 every day, $3 every day, and then just put it in an account and then let that bear interest, you will see that the money goes so much, you'll go up fast, so much faster. All right. So just be aware of that and just be careful of, or don't, again, the whole get rich quick schemes. Whenever you see something like that, please have your like caution lights on, please. Okay, do not ever like, hey, you have, and by the way, again, too, like when you're in your mid-20s, there's going to be 1,000,000 people, like your friends are going to come up to you and go, hey, you know, you want to join this with me? Hey, you want to do that? And hey, it's a no-brainer. It's a no-brainer. I did it myself, and you can do it too, kind of thing. Just be aware, like learn how to say no to your friends, especially your friends. Those are the hardest people to say no to. All right. And just be aware of like, because there's a lot of people who are, yeah, you end up being, and a lot of friendships are broken. Okay. So why do you think a lot of old people are kind of cranky? Because they've been burned by their friends so many times. Okay. So just be aware of that. Okay. All right. So here we go. All right. So let's graph this here. Let's graph this here. Again, that was that you get for free. All right. I'm not like, yeah, you guys do whatever. All right, here we go. So let's graph this thing right here. All right, so we have negative, I'm gonna put like 1 right here and 2 right here. Okay. All right, so -3, 1, 2, 3. Can you guys graph these points? Be like 1/8 is right here. And then 2 and 1/4 will be like right here. Goes up gradually. 1 and -1 and 1/2 is right here, right? Then 0 and 1 is right here. And then what? 1 and 2 is right here. 2 and 3 and 4, 5, 6, 7, 8. You know,
Thank you. Thank you.
You will see also like, again, so many analogies with this, like in the beginning too, like you think things are slow, like, I don't know, a lot of my friends, unfortunately, when they're in junior high school, like a lot of them like use drugs. You know, they were big smokers, chain smokers over and over again. I mean, they unfortunately, like they were, you know, they smoked all the time. And now you see them like, and he's, you know, like if they start smoking when they're junior high school kind of thing, right? And then now they're 40, 50 years old. Think about the impact of like that smoking and that all the drug use on your body over the course of like 30, 40 years kind of thing, right? And so now you're just seeing like people just being shriveled up and, you know, like they're just like, their skin is just all gone and, you know, it's just like they're barely talking everything, their voice is all gone and everything like that. It's because they were addicted, right? And like when they're at 10, 11 kind of thing. And then and it's just like, it's crazy, like how, you know, so everything kind of goes up exponentially, like even weight gain too. Like for me, I was telling you, like my volleyball team, like if I eat something now, I gain like 5 pounds. Like any like In-N-Out burger, I'm like, oh my gosh, I'm gonna gain like 5 pounds. Back then, I ate hamburgers, like I ate like 4 or 5 cheeseburgers. I could down, and my metabolism was super fast. Now it's like if I eat one little thing, it's like I'm gonna lose it. Like it's just like we get a stomach ache, whatever, so on and so forth. Anyway, you'll see like how jacked up everything gets once you guys get older. But again, this is a really powerful thing. All right, now here we go. So you see this, you see how this graph works, right? Let's go to Desmos real quick. All right, and let's check out these exponential. Let me go to this right here and then. All right. Here we go. All right, so y equals to the x power, right? You guys graph this? Right, that's this, right? That's what we just graphed right now. That's why it looks like this. By the way, what's the asymptote here? It's y equals 0, right? Because it's not going to go below 0, right? It's gonna get closer and closer, like -8, -9, -10. It gets really close, but it doesn't ever hit the x-axis. Okay, so the asymptote is y equals 0. Be aware of that. Okay. All right, now what happens if I put y equals 2 to the x power? Let me put in, oops, I put in parentheses, x minus 3. What happened here? It shifted to the right 3 times. So where's the inside? Where's the quote inside of the function? It's with the exponent, right? Okay, that makes sense. All right, so be aware of that. So if I put, let's just say, a 3 in front of the x. If I put a 3 in front of the x, what's going to happen? It's a horizontal shrink by 1/3. Now, what's the shift?
To the right.
To the right, how many times though? 3. Remember, it's 1, right? Because you have to factor out the 3, right? And so what? It's actually, so let's go with this right here. Let's go with this to the 3x power, right? Right? You see that? Oh, oops, wait, where did I go? Okay, you see that right here? So the parent function right here is what? The red, right? Okay, and look at what happened here. It just shifted 1 to the right, correct? Because remember, you have to factor out the 3 inside of the parentheses. Okay, so just be aware of what's going on there. How do I do the vertical stretches and shrinks now? Okay, so let's focus on that. So let's go here, x. Here's x. Let me go back to this here. Here's x. Now, if I shift up, it's just +4. You see what I did there? All right, the +4 is after. That's easy, right? Because you just go up 4, right? The +4 just has to be below, right? It's after the main function. But how do I, let's say, let me ask you this. How do I do a vertical stretch by 4? What do I have to do?
Oh, change the base of the x.
Not the base. The base stays the same. What, Giovanni, what were you saying? I think you mentioned it. Yeah, you have to put a 4 in front of the 2. Okay. All right. So that's how that works with this. Okay. So just be aware again of the different types of, and this is key. All right. So this is written, by the way, like I forget, it was y equals, I think it's y equals AB, y equals A and then B, and then what? X minus H plus K, something like that. Okay, yeah, this is a good way of putting it. Okay, the A tells you the vertical stretch or shrink. All right. The B is the base, which is the 2 right here. All right. The X is the exponent, obviously. The H is the shift to the right or left, and the K is the up and down. Okay. All right. And then if you want to shrink horizontally, you put a number in front of the X variable in the exponent. Okay. So let me put that on the. So here it is. So. You go back to this here. So you have y is equal to a, b, and then x minus h plus k. Okay. The a tells you if it's a vertical stretch or shrink. The h tells you the shift to the right or left. The k tells you what? The up and down, up or down. And then if you wanna horizontally stretch or shrink, it's a number in front of the x value. So I'm just kind of writing this quickly, right? Any questions on that? All right. Here's what I want you to do here now. I want you guys to graph the following here, okay? At least if you can graph the first two, that would be great.
On the same graph.
Yes. Yeah, and by the way, with this transformation, just put everything on the same graph. That kind of tells me like your shifts and stuff really well, okay? So try this. What does the negative do in front of the 4? What does the negative in front of the exponent do, okay? All right, I'm gonna stop the Zoom video real quick, so that way I'm saving time and I can reset the 40 minutes that I get. So